Hello students, in this lecture we'll solve more examples on uniform distribution. So example is, in a certain experiment, the error made in determining the solubility of a substance is a random variable having uniform distribution with a is equal to minus 0.045 and b is equal to 0.045. So this is negative and this is positive. What is the probability that such an error will be first is between 0.010 and 0.020. Second one, error between minus 0.025 and 0.030. So in this example you have to find out first distribution function or PDF of given uniform distribution, and we have to find out probability between 0.010 to 0.020, and second case find out probability between minus 0.025 and 0.030. So let's prepare first PDF. So solution. So X be the error made in determining the solubility of substance, determining solubility of substance, and X is the uniform distribution for minus 0.045 to 0.045. Okay, so this is uniform distribution. So what is PDF? So here what is A is minus 0.045 and B is 0.045. Okay, now to find out PDF. So what is PDF? So its PDF f of x is, PDF means what? Probability density function. So its PDF f of x is 1 upon b minus a. So b is, first case, b is 1 upon 0.045 minus plus 0.045. So it is on the interval minus 0.045 less than equal to x less than equal to 0.045. So and 0 otherwise case. So which is equal to, what will we get? So finally we will get 1 upon, so after addition 5 plus 5 0, 4 plus 4 8 plus 1 9, and 0.09 is the PDF 1 upon 0.090 interval minus 0.045 less than equal to x less than equal to 0.045 and 0 otherwise, right? So this is f of x, small f of x. Okay, now what we have to determine? So I will write here. So our function f of x is 1 upon 0.090 or interval minus 0.045 less than equal to x less than equal to 0.045. Okay, now we have to determine probability between 0.010 and 0.020. So first case, probability of 0.010 less than equal to x less than equal to 0.020. So by using for lower limit is 0.010 and upper limit is 0.020 into what is f of x. So here f of x dx, which is equal to integration 0.010 0.020. Upper limit is what is PDF? 1 upon 0.090 dx. So which is equal to, so this is constant, 1 upon 0.090 is constant. So integration is x, lower limit 0.010, upper limit 0.020. So which is equal to 1 upon 0.090 into upper limit is 0.020 minus lower limit 0.010. So which is equal to, after taking subtraction you will have 0.010 upon 0.090. So after cancellation law, after cancelling this point decimal, so we will get 10 upon 90. So we will get 1 upon 9 is the probability of 0.0190 less than equal to x less than equal to 0.020. Okay, so x is error made in determining the solubility of a substance. Okay, now in second condition, to find out probability from minus 0.025 to 0.030. So let's find out second probability. So second one, solution of second. Now to find out probability minus 0.025 less than equal to x less than equal to 0.030. So by using interval lowest limit is minus 0.025 and upper limit 0.030 into f of x dx. So which is equal to minus 0.025 upper limit 0.030 into what is f of x? F of x is 1 upon 0.090 into dx, right? So we'll get which is equal to 1 upon 0.090 constant outside. So integration of constant term is x. So lower limit minus 0.025, upper limit is 0.030. So which is equal to 1 upon 0.090 into upper limit 0.030 minus lower limit, minus here is plus 0.025. So which is equal to, finally what will we get here? 1 upon 0.090 into, so after adding this 0.055. Okay, so 0.055 upon 0.090. So here we get 55 upon 90. So we'll get 5.5 upon 9, and after solving it you will get the answer which is 0.6111. So this is the probability of minus 0.025 less than equal to x less than equal to 0.030. Okay, now next we'll see another example. The quantity per tin filled by a machine is uniformly distributed over 240 ml and 260 ml. What is probability that an oil tin is filled with more than 250 ml of oil. Further, if 25 tins are filled with oil, what is the expected quantity? Of oil consumed? So let's solve this problem. So in this problem we have given uniform distribution over the interval 240 ml and 260 ml. So let here x denote quantity of oil per tin filled by machine. Okay, so this is, I have defined x, and we have given that it is a uniform distribution over lower limit 240 ml to 260 ml. Okay, so then the PDF means probability distribution function of uniform distribution is f of x is equal to 1 upon b minus a. So 1 upon b is 260 minus 240. So on the interval 240 less than equal to x less than equal to 260. Therefore f of x is equal to, what is f of x? 1 upon 20 or on interval 240 less than equal to x less than equal to 260. Right? So what we have to find out here? So what is the probability that an oil tin is filled with more than 250? More than 250 means what? X is greater than equal to 250. So lower limit is 250 and upper limit will be 260. Therefore, now to find out probability of, so what is probability? More than 250 ml. Okay, more than 250 ml means what? Probability of x greater than equal to 250. So x greater than equal to 50 and upper limit is 260 means what? So lower limit is 250 and upper limit is 260. So into f of x dx. So which is equal to integration 250 to 260. So f of x is 1 upon 20 dx. So 1 upon 20 and integration of constant function is x, limit from 250 to 260. So which is equal to 1 upon 20, upper limit is 260 minus 250. Okay, so which is equal to 10 upon 20, then finally we will get 1 upon 2. So this is 0.5 is the probability that the machine or oil tin is filled more than 250 ml, which is 0.5. Now next, what we have to find here? Find what is the expected quantity of an oil is consumed. Means what? We have to find out an mean. Expected quantity of an oil means what? Find out mean. So here Further, if 25 tins are filled with oil, what is the expected quantity of an oil is consumed? Means find out mean of that given uniform distribution. Now mean is equal to E of x, which is equal to, so this is expected quantity. The formula is B plus A upon 2. So value of B is 260 and value of A is 240 upon 2. So which is equal to, after adding this, so 500 upon 2, which is 250, right? So here we have to find out further 25 tins are filled with oil. What is the expected quantity of an oil is consumed? So I will multiply E of x by 25. Therefore 25 into expected quantity is equal to, so 25 into 250, so which is equal to, so after multiplying this, 25 into 0, 25 into 5, 100, 25, so 12, 60. So total is 6,250 liter. So total quantity of oil consumed in liters is 6,250 liter. Okay. So here is the solution. Now let's see another example. So let's see this problem. So in this problem we have given suburban trains on a certain lines run every half hour between midnight and 6 in the morning. He find probably that a person entering the station at random time during this period will have to wait for at least 20 minutes. Also find probably that he has to wait between 12 minutes and 27 minutes. So in this example, what we have given, so see the solution. So here we have given, it is an uniform distribution. So we have given, what we have given here, suburban train on a certain line run every half hour between midnight and 6 in the morning. Find the product that a person entering the station at the random time during this period will have to wait for at least 20 minutes. Also find product that he has to wait between 12 minutes and 27 minutes. So we have to determine first uniform distribution. So x uniformly distributed. So here uniform distribution. So here suburban trains on certain line run every half hour. So run every half hour. So total there are 12 hours. Okay. So 12 hours. So 12 into half hour. So total there are 2 into 12. So how many hours are there? So total there are 12 into 2, which is equal to 24 hours. Means, so here there are total 24 trains will run in 12 hours, right? And also we have given 6 in the morning, right? So this 24 plus 6 in the morning, so total there are 30 trains run in that highway. Okay, so we'll start this train which is from 0 to 30. So uniform distribution is 0 to 30. Okay, so here value of x is lies between 0 to 30. Now this is uniform distribution. Here 0 to 30. Therefore its PDF, then its probability density function is f of x is equal to, what will we get? 1 upon b minus a. So 30 minus 0, which is 1 upon 30 whenever 0 less than equal to x less than equal to 30, right? And 0 otherwise. Okay, so you have to understand this uniformly distribution from 0 to 30, because what we have given here, on a certain line run every half hour. So total there are 12 hours. Okay, and every half hour means what? In 1 hour there is 2 half hours. So we'll get 2 into 24, 2 into 12, which is equal to 24. So in 12 hours there will be 24 trains will travel, okay, and in morning 6 in the morning will travel. So 24 plus 6 is equal to 30. So total uniform distribution which is from 0 to 30. So from that we have to determine the probability density function which is 1 upon 30. Okay, so here this is PDF. Now what we have to find here? So find the probability that a person entering the station at random time during this period will have to wait for at least 20. At least 20. Right? At least 20 means what? So to find out probability of person to wait at least 20 minutes. At least 20 minutes means what? So lower limit is 20 and upper limit is 30. So which is probability of x greater than 20. So lower limit is 20 and upper limit is 30. F of x dx. So which is equal to integration 20 to 30. F of x is 1 upon 30 into dx. So 1 upon 30 outside. So integration of constant function is x. Limit from 20 to 30. So which is equal to 30 minus 20 upon 30. So we'll get 10 upon 30. So final answer is 1 upon 3. So probability of person to wait at least 20 minutes is 1 upon 3. Now next we have to determine probability of person to wait 12 minutes to 27 minutes. So which is 12 less than x less than 27, which is equal to, so lower limit is 12, upper limit is 27 into, so x, so here is f of x dx, so which is equal to integration 12 to 27. F of x is 1 upon 30 dx. So 1 upon 30 outside. So integration of constant function is x. Limit from 12 to 27, which is equal to upper limit 27 minus 12 divided by 30. Right. So after subtraction we'll get 15 upon 30. Again we'll have answer is 1 upon 2. So here probability of 12. So person waiting 12 minutes to 27 minutes has probability 1 upon 2. Now let's see. So last example of this point on uniform distribution is, so we'll see example. Suppose x is an uniform distribution over 2 to 25. Find mean and variance. Find mean and variance. Mean and variance. And determine find probability of x less than 7.8 and probability of x less than 11 given x less than 19. So this is probability x less than 11 given x less than 19. Now let's solve this. What we have given? X is an uniform distribution over 2 to 25. So from that we have to calculate mean and variance. So here value of A is 2, value of B is 25. Therefore value of mean. So mean is equal to E of x. So what is mean of uniform distribution? Mean of uniform distribution is A plus B upon 2, which is 2 plus 25 upon 2, which is 27 by 2. So answer is 13.5. Okay, now next we have to determine variance. Now variance of uniform distribution is what is formula? Variance of x is equal to b minus a bracket square upon 12. So b has value 25 minus 2 bracket square upon 12, which is equal to, so 25 minus 2, which is 23 bracket square upon 12. So the square of 23 is 529. So 529. So final answer after dividing it we will get 45. Okay. Now we have to find out probability of x which is less than 7.8. Okay. So probability of x less than 7.8. So less than 7.8. So here lower limit is 7.8 and upper limit is 25. Okay. Sorry here less than x is less than 7.8. So lower limit is 2 and upper limit is 7.8. So probability integration 2 to 7.8 f of x dx, which is equal to integration 2 to 7.8. So what is our f of x? So from that we have to find out f of x is 1 upon b minus a. So value of b is 1 upon 25 minus 2, which is 1 upon 23. So this is f of x on interval 2 less than equal to x less than equal to 25. Okay. So here 1 upon 23, right? 1 upon 23 into dx, which is equal to 1 upon 23 outside into, so integration of constant function is x, limit from 2 to 7.8. So 7.8 minus 2 upon 23, which is 5.8 upon 23. So you can calculate on calculator, will get the answer. It is 0.2517. Also next we have to find out probability x less than 11 given x less than 19. Okay. So let's determine this. Probability of x less than 11 given x is less than 19. So we know that the formula probability of a given b is probability of a intersection b upon probability of b, right? So here we will get probability of x less than 11 intersection x less than 19 divided by probability of x less than 19. Okay. So here we know that what is our interval. So our interval is 2 to 25. So here x is less than 11 and here x less than 19. So what is common interval? So here first interval is here our lower limit is 2 and upper limit is 11. So here is first interval and second interval here is 19, 2 to 19. So what is the common interval? So common interval between these two is 2 to 11. So probability of 2 less than x less than 11 upon probability of x less than 19. Now we have to determine probability between 2 less than x less than 11 and probability of x less than 19. Now let's calculate this. So probability of this is, so we will get, to determine probability of 2 less than x less than 11 is equal to integration 2 to 11. So what is our f of x? 1 upon 23 dx. So 1 upon 23 into upper limit 11 minus 2 will have 9 by 23. Okay. And probability x less than 19. So probability of x less than 19. So upper limit is 19, means lower limit is 2 to 19 f of x dx. So what is our f of x? F of x is 1 upon 23, which is equal to 1 upon 23 into x, lower limit 2 to 19, which is equal to 1 upon 23. So upper limit 19 minus 2, which is 17 upon 23. So substituting this value will get, so this is 9 upon 23 divided by this is 17 upon 23. So we'll have 23 get cancelled. So I can write here 9 by 23 into 23 by 17. So which is get 23 get cancelled, 9 by 17. So after calculating it we will get 0.5294. Okay, so this is our final answer. Now here we will stop. In next lecture we will see binomial expansion. Thank you.